Hello there, and welcome to Drift with Science. Tonight, we're slowly drifting toward Voyager 1, a small spacecraft, moving gently through the endless dark of space, millions of miles away, where everything is quiet and nothing is in a hurry. And if this calm journey brings you peace, you can softly support the channel so more minds can rest and drift into deep sleep with science. Voyager 1, the farthest human object. There is a region beyond the planets, far beyond the warmth of the sun, a place where sunlight is faint, where space is almost perfectly silent. In that darkness, something made by human hands is still moving. It does not stop. It does not turn back. It does not even know it is alone. This is Voyager 1, the most distant object ever created by humanity, and it is still sending signals home. Very faint signals, traveling for more than 22 hours before reaching Earth. But to understand how it reached that distance, we need to go back to the year 1977. In the 1970s, scientists noticed something rare. The outer planets were aligning. Jupiter, Saturn, Uranus, Neptune. This alignment happens only once every 176 years. It created a unique opportunity. A spacecraft could use gravity from one planet to travel to the next, like stepping stones across the solar system. NASA decided to act. They built two spacecraft. Voyager 2 launched first. Voyager 1 launched on September 5th, 1977. Even though it launched second, it was placed on a faster path. Its mission was simple: visit Jupiter, visit Saturn, collect data. The mission was expected to last about 5 years. No one expected it to survive for decades. In March 1979, Voyager 1 reached Jupiter. For the first time, humanity saw the giant planet up close. The Great Red Spot was larger than Earth. Storms rotated with enormous energy. Lightning flashed in thick clouds. Radiation surrounded the planet. But the biggest surprise came from a moon, Io. Before Voyager, scientists believed most moons were frozen and inactive. Voyager proved that assumption wrong. It photographed volcanoes erupting, plumes rising hundreds of kilometers into space. Active geology on another world. It changed our understanding of the solar system. The outer planets were not silent. They were dynamic, alive with motion. In November 1980, Voyager 1 reached Saturn. Saturn's rings appeared delicate from Earth, but up close, they were complex. Thousands of thin ringlets, gravitational interactions shaping their structure, small moons guiding the edges. But one moon stood out: Titan. Titan had a thick atmosphere, dense, orange, mysterious. Scientists believed it might contain organic chemistry, possibly similar to early Earth. NASA faced a decision: continue outward toward Uranus and Neptune, or redirect the spacecraft to study Titan more closely. They chose Titan. The flyby gave valuable data, but it also changed Voyager 1's trajectory forever. Instead of continuing along the planetary path, Voyager 1 was sent upward, out of the flat plane of the solar system, into deep space. Its planetary tour was complete. Its interstellar journey had begun. After Saturn, there were no more planets ahead, only distance. Voyager 1 kept moving outward, past the orbit of Pluto, farther than any spacecraft before it. The sun's gravity still held it, but its influence was weakening. The solar wind streams outward from the sun, charged particles moving in all directions. Eventually, that solar wind meets the interstellar medium, the space between stars. The boundary between these regions is called the Heliopause. Crossing it would mean entering interstellar space. For decades, Voyager moved closer to that boundary, measuring particles, measuring magnetic fields, recording subtle changes. Then, in 2012, it happened. Voyager 1 crossed the Heliopause. It became the first human-made object to enter interstellar space, not leaving the sun's gravity entirely, but leaving the sun's protective bubble. A quiet milestone. No fireworks, no dramatic explosion, just data, a shift in particle density, a change in magnetic field strength, and confirmation. Humanity had extended its reach beyond the solar wind. Today, Voyager 1 is more than 24 billion kilometers away from Earth. Its signal travels at the speed of light. Even so, it takes over 22 hours to arrive. When NASA sends a command, it takes almost 2 days to receive confirmation. Communication is slow, careful, deliberate, yet it continues. A fragile connection stretched across interstellar space. And still, Voyager listens and answers. After leaving Saturn, Voyager 1 entered a region where there were no more planets waiting, only distance and darkness. But what does distance really mean in space? On Earth, distance is simple. You drive 10 kilometers. You walk 1 kilometer. But in space, distances are so large that kilometers become too small to use. So scientists use a different unit. A light year. A light year is not time. It is distance. It means how far light travels in 1 year. Light moves at about 300,000 kilometers every second. Every second, in 1 minute, light travels about 18 million kilometers. In 1 year, light travels about 9 trillion kilometers. That is 1 light year. 9 trillion kilometers. Voyager 1 is not 1 light year away, not even close. It is about 24 billion kilometers away, which sounds large, but compared to 1 light year, it is still very small. That shows how huge space really is. As Voyager moved farther from the sun, it entered a strange boundary. This boundary is called the Heliopause. Let us understand that slowly. The sun constantly releases tiny charged particles. These particles flow outward in all directions. This flow is called the solar wind. It is not wind like on Earth. It is not air. It is a stream of tiny particles, protons, electrons, moving very fast. This solar wind creates a kind of bubble around our solar system. Imagine blowing air into a balloon. The air fills the balloon. The balloon expands outward. In a similar way, the solar wind creates a giant bubble in space. That bubble is called the heliosphere. Inside this bubble, the sun's influence is strong. Outside this bubble, the galaxy becomes stronger. The heliopause is the edge of that bubble, the exact point where the sun's wind becomes weaker than the space between stars. In 2012, Voyager crossed that edge, very quietly. No sound, no visible line, just changes in data. The instruments measured more cosmic rays. Cosmic rays are very high-energy particles that come from outside our solar system, from distant stars, from exploding stars, from violent cosmic events. When Voyager detected more of these particles, scientists understood it had stepped into interstellar space. Interstellar means between stars. Now imagine this. Voyager is no longer protected by the sun's bubble. It is exposed to raw galactic space. The temperature there is extremely cold, close to minus 270 degrees Celsius. Almost absolute zero. Absolute zero is the coldest possible temperature, the point where atoms barely move. And yet, Voyager continues, because it carries its own power source. It does not use solar panels. There is not enough sunlight that far away. Instead, It uses something called a radioisotope thermoelectric generator. That sounds complicated, but it is simple. Inside Voyager, there is a small amount of plutonium. Plutonium is a radioactive material. Radioactive means it slowly releases energy as it breaks down naturally. As it releases energy, it produces heat. That heat is converted into electricity. No moving parts, no engine, just slow natural decay, like a very long-lasting battery. But even this battery is fading. Each year, the power decreases slightly, and because of that, engineers must turn off instruments, one by one. First the cameras, then some heaters, then certain sensors. Each shutdown is permanent. There is no restart button, only careful choice. Communication is becoming harder. Voyager's transmitter is only about 23 watts. To understand that, a small household light bulb can use more power. Yet that tiny signal travels billions of kilometers until it reaches Earth. How does Earth hear it? Using giant radio antennas. Some of them are 70 meters wide. That is almost the length of a football field. These antennas listen carefully, filtering out background noise, searching for a faint signal, like trying to hear a whisper during a storm. And still, they find it. A steady tone, a quiet digital voice from the edge of the solar system. Sometimes problems happen. Voyager is old. Launched in 1977. That was before most modern computers existed. In 2023, Voyager started sending strange data. The signal was strong, but the information made no sense. Like scrambled words. Engineers on Earth had to solve the mystery. But here is the challenge. Any command takes about 22 hours to reach Voyager, and 22 more hours for a reply. Almost 2 days. So every test is slow. Every correction takes patience. Eventually, they discovered part of the onboard memory was damaged. Memory means the storage system where instructions are kept, like a very old hard drive. Instead of giving up, engineers rewrote the software. They moved important code to a different memory location, and Voyager recovered. A machine billions of kilometers away, fixed through careful human thinking. That is not dramatic. It is quiet dedication. Now let us talk about something peaceful. Motion. Voyager is not using fuel. It is not accelerating. It is simply continuing at the speed it gained from gravity assists. A gravity assist is when a spacecraft uses a planet's gravity to increase speed. Imagine throwing a ball at a moving train. If done correctly, the ball can bounce off with more speed than it had before. In space, planets move around the sun. When Voyager passed near Jupiter and Saturn, it borrowed a tiny bit of their motion. That is how it gained its high speed. About 17 kilometers per second. That is over 60,000 kilometers per hour. Even at that speed, it would take over 40,000 years to come close to another star. And even then, it would not stop. It would simply pass by. There is something deeply calming about Voyager's journey. It has no deadline, no pressure, no expectations now. It simply continues through a region of space that is almost completely empty. On average, interstellar space contains only a few atoms per cubic centimeter. That means if you take a cube the size of a sugar cube, inside it, there may be only a few lonely atoms. That is how empty it is. And through that emptiness, Voyager moves, quietly, steadily, patiently. One day, probably sometime in the 2030s, the remaining instruments will lose power. The transmitter will shut down. The signal will stop. Earth will listen and hear nothing. No tone, no whisper, just silence. But silence does not mean the end of the journey. It only means the end of communication. Voyager will continue drifting around the center of our galaxy, Our galaxy is called the Milky Way. It contains hundreds of billions of stars. The Sun is just one of them. And Voyager will orbit the center of this galaxy, taking about 225 million years to complete one full circle, just like our Sun does. Long after Earth changes, long after continents shift, long after humanity evolves or disappears, Voyager will remain, a small metal object, carrying a golden record, a record filled with sounds of Earth, music, greetings, laughter, a heartbeat. Even if no one ever finds it, it still exists. A message placed gently into the ocean of space. Not to impress, not to conquer, but simply to say, we were here, we were curious, we reached outward. Attached to the side of Voyager 1, there is something unusual, not a sensor, not a camera, not a scientific instrument, but a message, a physical message, made of gold-plated copper. It is called the Golden Record. It looks like a vinyl record, like the kind used to play music decades ago. But this record was not made for humans. It was made for anyone intelligent, anywhere in the galaxy. Let us understand something important. The chances of Voyager being found are extremely small. Space is enormous, almost empty. The distance between stars is measured in light years. Remember, 1 light year is about 9 trillion kilometers. That is 9 followed by 12 zeros. Space is not crowded. It is mostly silence. So the Golden Record was not created with expectation. It was created with hope, a quiet kind of hope. The record contains sounds from Earth, natural sounds, wind moving through trees, rain, thunder, ocean waves, birds singing. There is even the sound of a heartbeat and the cry of a baby. Simple sounds, but deeply human. It also contains greetings in 55 different languages. People saying hello, people wishing peace, in languages from across the world. It is a reminder that Earth is diverse, different cultures, different voices, one planet. There is music too, music from different civilizations, classical music, traditional music, songs chosen carefully, not to represent power, but to represent beauty. Because if someone finds Voyager, they will not know our politics, they will not know our history, but maybe they could understand rhythm, harmony, emotion. There are also images stored on the record, but not printed as pictures. Encoded. Encoded means the information is converted into a pattern, like a hidden code. Instructions are engraved on the cover, showing how to decode it, using universal science. For example, there is a diagram of the hydrogen atom. Hydrogen is the simplest atom in the universe. It exists everywhere, so scientists assumed any intelligent civilization would understand hydrogen. The record uses hydrogen's properties as a time reference, a universal clock, because physics is the same everywhere. Gravity works the same way. Light behaves the same way, no matter which planet you are on. There is something very peaceful about that idea. Even across billions of kilometers, the laws of physics remain the same constants, the same rules, as if the universe speaks one silent language. And Voyager carries that language engraved in metal. Now let us move to a different moment. The year 1990. Voyager 1 was already far beyond Saturn. Its main mission was complete. NASA decided to turn its cameras off permanently to save power. But before doing that, they gave it one final command. Turn around. Look back at Earth. From nearly 6 billion kilometers away, Voyager captured an image. In that image, Earth appears as a tiny pale blue, less than 1 pixel, floating in a beam of scattered sunlight. That image became famous. It was later called the pale blue dot. The name was inspired by astronomer Carl Sagan. He reflected on what that tiny dot meant. Think about it slowly. Every human who ever lived on that dot. Every war, every love story, every invention, every dream, every argument, every moment of joy happened on that tiny pixel. From Voyager's perspective, Earth is almost invisible, and yet it is everything to us. The image does not make us feel small in a negative way. It makes us feel connected. It reminds us that borders do not exist from space. There are no lines between countries, no visible divisions, just one fragile sphere, suspended in darkness. Voyager did not judge. It did not comment. It simply recorded what it saw. A pale blue dot. Quiet. Alone. Beautiful. There is something deeply calming about perspective. When we think about daily problems, stress, deadlines, conflicts, they feel large, heavy, important. But from 6 billion kilometers away, they disappear. The Earth itself becomes barely visible. That does not mean our lives are meaningless. It means they are precious, because they happen in a rare place. A thin atmosphere, liquid water, stable sunlight. These conditions are not common. They are fragile, and Voyager showed us that, without saying a word. Now Voyager no longer takes pictures. Its cameras are silent, but the pale blue dot remains. A final glance backward, before heading permanently into deep space. It was like a quiet goodbye, not dramatic, just gentle, a last look home. Today, Voyager continues outward. It carries the golden record. It carries that image in our memory. It carries the idea that humanity once reached beyond its planet, not to conquer, but to explore, to understand, to listen. And somewhere, in the deep darkness between stars, a small spacecraft moves forward. No sound, no light of its own, just momentum, just purpose, just a quiet message, traveling through eternity. Right now, Voyager 1 is about 24 billion kilometers away, but that number will keep increasing. Every second, 17 kilometers farther. That is its speed. 17 kilometers every second, which means in 1 minute, it travels more than 1,000 kilometers. In 1 hour, more than 60,000 kilometers. And it never slows down, not in any noticeable way, because space is almost empty. There is almost nothing to stop it. Now let us move forward in time, not years, not centuries, but thousands of years. In about 40,000 years, Voyager will pass near another star. The star is called Gliese 445. It is a small red star, much dimmer than our sun. Voyager will pass about 1.6 light years from it. Remember what a light year means. It is the distance light travels in 1 year, about 9 trillion kilometers. So 1.6 light years is about 14 trillion kilometers. That is still very far. Voyager will not enter orbit. It will not land. It will simply pass by, like a silent traveler crossing a distant neighborhood. Now let us move even further, millions of years into the future. By then, human civilization will be unrecognizable, or it may not exist at all. Species evolve. Species disappear. On Earth, most species that have ever lived are now extinct. Extinct means they no longer exist. Dinosaurs once ruled the planet. Now they exist only as fossils. Humanity is not guaranteed permanence. Nothing biological is. But Voyager is not biological. It does not age in the same way. It does not feel hunger. It does not need air. It does not fear extinction. It simply drifts. Now let us go billions of years ahead. About 5 billion years from now, the sun will change dramatically. Right now, the sun is stable. It produces energy by fusing hydrogen into helium. Fusion means small atoms combine to form larger atoms. When that happens, energy is released. That energy is what warms Earth. But the sun will not burn forever. In about 5 billion years, the sun will run low on hydrogen in its core. It will begin to expand, becoming what is called a red giant. A red giant is a late stage of a star's life. The outer layers expand outward, possibly reaching the current orbit of Earth. Earth's oceans may evaporate long before that. Life as we know it will not survive that transformation. The inner solar system will change completely. But Voyager will be far away by then, far beyond the outer planets, far beyond the sun's expanding outer layers. It will not be swallowed. It will not be burned. It will continue orbiting the center of the Milky Way galaxy. Let us understand that orbit. Our galaxy is a vast spiral structure, containing hundreds of billions of stars. Our sun orbits the center of this galaxy. It takes about 225 million years to complete one orbit. Voyager will follow a similar path, not because it chooses to, but because gravity guides everything. Gravity is the force that attracts objects with mass toward each other. It keeps planets around stars, stars around galaxies, galaxies around clusters. Even Voyager cannot escape gravity entirely. It is always under some influence, but that influence is gentle now, wide, slow, cosmic. Over billions of years, micrometeorites may strike Voyager, tiny particles of dust, smaller than grains of sand, traveling at high speeds. They may slowly erode its surface. Radiation from distant stars may damage its structure, but space is so empty that large collisions are extremely unlikely. Voyager may remain mostly intact for billions of years, longer than mountains on Earth, longer than oceans remain stable, longer than civilizations last. Imagine that, a small machine built in the 1970s, outlasting continents, outlasting species, outlasting the current shape of the solar system. There is something deeply humbling about that. Now consider this. Voyager has no awareness. It does not know it carries a message. It does not know it crossed into interstellar space. It does not know Earth exists. And yet, it represents one of humanity's greatest achievements. Curiosity, exploration, the willingness to look beyond the horizon. There is a quiet lesson here. Civilizations rise and fall. Technology changes rapidly, but the desire to explore, to ask questions, that is what defines intelligence. Voyager is a symbol of that desire. Not loud, not aggressive, just persistent. In the distant future, perhaps another civilization may find it. Perhaps not. But even if no one ever sees it again, it has already fulfilled its purpose. It expanded our understanding. It showed us Jupiter's storms, Saturn's rings, volcanoes on Io, the thin boundary of the Heliopause. It gave us the pale blue dot, and with it, perspective. Perspective is powerful. When we understand how vast space is, our conflicts seem smaller. Our differences seem less important. We all share the same fragile planet, the same thin layer of atmosphere, the same sunlight. Seen from billions of kilometers away, there is no separation, only one pale blue world. Voyager continues. No noise, no engine burn, just silent motion through interstellar space, carrying a golden record, carrying memory, carrying proof that once, on a small blue planet, intelligent life looked at the stars and reached back. Right now, as you are listening, Voyager 1 is still moving, 17 kilometers farther. Every second, it does not pause. It does not hesitate. It simply continues. Somewhere in California, or Spain, or Australia, a large radio dish may be listening, waiting for a faint signal, a whisper from deep space. The signal is weak, so weak that by the time it reaches Earth, it is billions of times fainter than when it left Voyager. But it is still detectable, still real, still present. That signal is not a voice. It is not words. It is radio waves. Radio waves are a form of light, not visible light, but part of the same electromagnetic spectrum. The electromagnetic spectrum is simply all types of light, from radio waves to visible light to X-rays. They are all the same thing, just different wavelengths. Voyager sends radio waves. Earth listens, and for now, the conversation continues. But one day, the power will be too low. The transmitter will shut down. There will be no final message, no dramatic farewell, just silence. The Deep Space Network will listen and hear nothing. That will be the end of contact, not the end of Voyager, only the end of communication. After that moment, Voyager will become a completely silent traveler. No one will track it precisely anymore. No data will return. It will fade into the background of the galaxy, but it will still exist, still moving, still carrying the golden record. Think about that record again. Inside it are sounds of wind, rain falling, ocean waves, music played by human hands, laughter, a heartbeat, all sealed in metal, traveling through space. Long after the people who chose those sounds are gone, long after languages change, long after cities disappear, the record will remain, a quiet archive of Earth. It is possible that millions of years from now, no human will remember Voyager. History fades, records are lost, civilizations forget, but Voyager will not forget, because it does not need memory. Its existence is its memory. Its trajectory is its story. There is something deeply peaceful about that idea. A machine that does not rush, does not argue, does not demand attention. It simply moves forward, without fear, without regret, without expectation. When we look at the night sky, we see stars, but we do not see Voyager. It is too small, too far away, invisible to the human eye, and yet, it is there, crossing the space between stars, representing a moment in time when humanity chose curiosity over comfort, exploration over isolation. The pale blue image showed us our smallness, but Voyager shows us something else. It shows us capability. A species living on a tiny planet managed to send a machine beyond its star, not by accident, but by understanding physics, understanding gravity, understanding light, understanding mathematics. These are not small achievements. They are quiet miracles. We often think of greatness as loud, explosions, victories, power. But Voyager's greatness is silent. It is measured in distance, in patience, in endurance. It does not shine brightly. It does not glow. It simply persists. And maybe that is the most important lesson. In a universe that is billions of years old and billions of light years wide, persistence matters. Curiosity matters. Reaching outward matters, even if no one answers. Imagine drifting in complete darkness. No sound, no light nearby, only distant stars, tiny points of white. Voyager drifts through that darkness now, not lost, not afraid, just following the path given to it, a path shaped by gravity and human intention. As the sun continues its journey around the galaxy, Voyager travels too, a companion at great distance, one silent, one shining, both moving through cosmic time. If one day, far in the future, an intelligent being finds Voyager, they may examine its structure, they may decode its record, they may learn that on a small blue planet, there once existed a civilization, curious, creative, aware of its smallness, yet brave enough to explore. And if no one ever finds it, that is also fine, because Voyager was never truly about being discovered. It was about discovery itself. It was about looking outward, and in doing so, learning something about ourselves. Right now, Voyager is farther from Earth than any other human object, and every second, that distance grows. But in another sense, it keeps us connected to the universe, a reminder that we are not confined to our planet, not limited to our horizon, not trapped by our gravity forever. Somewhere in the vastness, a small spacecraft moves forward, carrying golden echoes of wind and music, carrying the memory of a pale blue world, carrying the quiet proof that intelligence once bloomed on Earth. And now, it drifts through cold interstellar space, through near-perfect silence, through darkness older than humanity itself, still moving, still existing, still traveling, 17 kilometers farther, every second, into eternity. Good night.